Hello. So today we will talk about the probability of flipping heads on a biased coin. Today is definitely March 3rd, not 4th. Not sure why that copied that, but today's March 3rd. It's on time. So getting into it, I imported my libraries and I set my parameters because it is a biased coin. I didn't set it at 50%. I set it at 70% probability of getting heads. And I set my other parameters, confidence level at 95%, and the confidence interval at 5% as well. And I went ahead and set my variables um, so that when I do the calculations later in the code, they'll already be set. So I used a if-else loop here to do the random flipping, simulating a flip of the coin. If it's heads, increase the head count by one. If it's tail, increase it by one. And I use that for each one. We get the Bayesian estimate. We use the formula basically, head count divided by head count plus tail count. And keep appending those, add and get, so that we can use it to get the confidence interval here. And this just keeps running. This is doing a loop until we get to a point where they're outside of the confidence interval. So once it gets outside, it will stop. And to visualize that, here you'll see the graph where it starts out very unstable, the Bayesian estimates, and then as time goes on, it kind of stables and converges to the probability. So you can see here, it stopped at around 326 flips of the coin of within that confidence interval. As you can see below, the final Bayesian estimate was 0.689 or 69%, 326 flips to get that heads in the confidence interval. And this is the interval of where we found that confidence level.